All right, hello folks. We are starting chapter 11 today, and chapter 11 has to do with areas, and I think we dabble a little bit in volumes, and I want to do some of this stuff before some of you juniors take the ACT soon. Soon. That's crazy. Areas of quadrilaterals is where they're starting off today. There's a lot of examples, but most of these are pretty short. First and foremost, quadrilateral, that's a big word. We had a whole chapter about quadrilaterals, but what is a quadrilateral? Let's do some examples. Four sides, four-sided figures. Okay. A lot of quadrilaterals fall underneath of parallelograms. Do you know what a parallelogram is? Parallel, P-A-R-A-L-L-E-L-O-G-R-A-M. There you go. Two sets of parallel sides, right? Parallelogram. So we're going to do parallelograms. What else? What other four-sided figures do we have?
Rhombus.
Yeah. Rectangle and square fall under parallelograms, right? A rhombus is also under a parallelogram. What else?
A triangle.
Triangle is not a four-sided figure.
Pentagon.
Nice try. A what?
Pentagon.
A pentagon is not a four-sided figure.
Bang.
Okay, what else? How about
A kite.
a kite?
Yeah.
What else? There's one more that I'm thinking of.
No way. There is way.
A kite, there's one more that I'm thinking of.
Isosceles.
Cylinder.
What was it?
What?
I can't.
It doesn't have to be isosceles.
Okay, never mind.
Dodecahedron.
Starts with a T.
Trapezoid.
Trapezoid.
Yeah.
Oh.
Okay. Do you guys remember when we did that whole big grid that had like
think
six
I-
little things on it, right? Those were the six
Oh.
things. Parallelogram, rectangle, square, rhombus, kite, trapezoid.
Right.
Those were all on that sheet, okay? So there is that. Now we're finding areas of all of those. How the heck do we find area? Let's do this. Parallelogram. All of these are going to be base times height. Base times height, base times height, base times height, base times height. That's how you find area of a four-sided figure is base times height. Except sometimes, like with a parallelogram, your base is here, your height is not the slanted one. So the thing to pay very, very close attention to is whatever your base is, your height must be perpendicular at a 90-degree angle to the base. Yeah? Okay. So that's how that works. Base, height, perpendicular, all that good stuff, okay? Now, the reason why, shut that off. The reason why this works is that if I then try to make this into a rectangle, check this out. Look at my diagram. If I lump this side off and I slap it over here, it will make a perfect rectangle. You see that? If I slide it over with a base of this guy and a height that's perpendicular, okay? So that's what they're saying right here is that I can take that and shift it over, okay? Here we go. Find the area of the parallelogram. Area is base times height. Base, height. What's the base?
7. Well, of.
Is it 23? Is it 30? Is it 7? Which one is it?
Well, we can do 30
The
and then
base.
take away the.
We don't have to do
I
that.
don't have to do this.
It is just 23, okay? The base is only the base of the figure, so only 23. 23 units or 23 feet. Height, do we have height?
It's not 25.
It's not 25.
It's 24.
The height is going to be this guy right here.
Wait, is that triple?
That is a triple. 7 is the bottom. 25 is the hypotenuse. This guy would be 24. So the height is 24. That's a triple. 7, 24, 25 is a triple, if you can remember that. Otherwise, do the Pythagorean theorem. 7 squared plus, we'll go b squared equals 25 squared, and then you find that b equals 24. Okay, you can do it that way as well. But then that means my area is 23 times 24. 552, whoa, what?
Feet squared.
Feet squared. All of these areas are in square feet. Feet squared. Good? Not so bad. Area of a parallelogram. Base height. The height is the perpendicular height. Okay? Example 2. Ooh, man, oh man. All right. We need just base and height, right? Base, height. What's the base? Is it 9?
17.
17 is the base. It's the whole base across here. 17 is that guy. This would also be 17, agreed? So 17 is the base. But then the height.
Do we do.
It's a 45, 45, 90.
Yeah. So height
That's
here is what I'm trying to figure out. This is a 45, 45, 90 triangle. And if that's a 45, 45, 90 triangle, that means those two sides are going to be the same, which means my height is
9.
9. Right? Do we know that that's the same thing, right? Let me see if they do another one to you. Okay,
17
yeah.
times
What does that come out to be?
153.
153 yards squared. Okay, now let's suppose, because some of you are like, I don't know, that's 9, whatever, right? Okay, all right, here, let's do this, because they might do this to you on a homework problem, okay? Let's call this height X, or we could call it H, whatever. Let's call it H, okay? Let's just focus on this triangle right here. That guy. 45 degrees is this angle, 9 is this guy here, right? We could do the SOHCAHTOA thing. Have we done SOHCAHTOA stuff in here yet? Yeah. Okay. So if we're doing 45 degrees, H is going to be the opposite, 9 is the adjacent. So we're going to use which trig function? Tangent. Tangent of 45 is equal to opposite, which is H over 9. And then you multiply the 9 to the other side. 9 times tangent of 45 is 9 also, right? 9 is that guy. So if you don't remember the 45, 45, 90 triangle thing, you could do also use SOHCAHTOA to find the missing side or the missing height, whatever. 153 yards squared. Perfect. Next. Trapezoids. That's the next one. Okay. Here is what a trapezoid looks like. All right. Ready? Check this out. It's still going to be base times height. Every object that we have here, we try to make it into a triangle. Now, we're assuming that this is an isosceles trapezoid. Okay? All right, so let's do this. If we take this guy, we can lump him over here and make this into a rectangle, true? Yeah? Okay. But the height is going to be this height right here. What's this base going to be? It's longer than this one, right? But it's not quite as long as that one. True?
So that the bottom
Right, do you
one
see this
plus
base?
The bottom of the triangle, or just the top minus the bottom of the triangle. Right?
Yeah, right. But how long's the triangle? That's the problem. Let's say that this base up here is 10 units and that this base right here is 8 units.
It's 2. Right?
It's 1.
No, it's 2, isn't it?
This is going to be 1 and this is going to be 1 right here, right? So the base of the triangle is 1. Or what's the base of this whole thing right here?
Oh, okay.
What's the base of that rectangle going to be then?
9.
9. How do you know it's 9? It's the average of the two. 8 and 10 together, average is 9, so the base is 9, right? Here is the formula for finding the area of a trapezoid. Ready? Area of anything is base times height, yeah? Here is where the height goes. But to find the base, they're taking 1/2 times base 1 plus base 2. 1/2 times base 1 plus base 2 is the average of the bases. Average of the bases times the height. Okay, because I have two bases that are different sizes, I'm taking the average of the two bases times the height. What are you doing?
Can you write a pass for us to come in here and work on our stats review so we don't get yelled at?
Yeah. I bet I could afford
Does she care that
no,
you were in
she
here?
wants us to work on other stuff. We have our work done for that class. We just can't do anything without pass. Thank you.
All right, so in the formula, the 1/2 base 1 plus base 2 is just taking the average of the two bases times the height. Okay, example 3. Here we go. This is like a flower patch or something, okay? What are my bases?
1.5 and 8.
1.5 and 8. Okay? So if I'm trying to find the base, I average those two together because I have two different bases, 1.5 and 8. Okay? So if I'm trying to average them, I add them together and divide by 2, or I take 1/2 of them added together, right? What's 1.5 plus 8 divided by 2? 9.5 divided by 8. 4.75? So 4.75 is going to be the base. Do we understand how that works? Here's the base. What's the height? 7, right? Like this is like laying down on its side. So 4.75 times 7 is something.
33.25.
33.25 feet squared. Make sure you're squaring everything. Questions about that? We have two different bases, so what base do we use? We use the average, right? Okay, that's a trapezoid. Moving on. Use right triangles to find the area of a trapezoid. All right. Base times height. My two bases are 2 and 4. So what do I use for a base?
1. No, wait.
What?
3.
2 and 4. The average of 2 and 4 would be 3,
Listen.
right? So my bases could be 3.
thinking
Okay,
of
what's
the
the
right
height though?
1 squared plus, or no,
Let's see.
C is 3.
Height is not 3, right? Height is this guy right here. That's what we need, okay? How long is this thing? Is the bottom of this triangle. Like, it would be the same on this other side, bottom of this triangle. If the whole bottom is 4, and then that middle chunk is 2, what's each of those little triangles gonna be?
1.
For a base, 1, right? So this is 1 and this is 1, okay? So the bottom is 1, the hypotenuse is 3, so this height would be 1 squared plus, we'll call this x. X squared equals 3 squared. 1 plus x squared equals 9, yeah? And then x squared equals 8, the square root of 8, whatever that is,
2.83.
2.83. That's gonna be my height, 2.83. 2.83, and then I take that times 3, and I get an area,
8.49.
8.49. And that is in centimeters squared. Okay, do you see how we do that? Your base is the average of the two bases. To find the height, you might have to do the Pythagorean theorem, or you might have to do some SOHCAHTOA stuff, right? So it's a little bit tricky. Am I going too fast? Okay, kites and rhombuses, okay? Here is a rhombus, and a rhombus we already know how to do because it's a parallelogram. So you're literally just doing base times height, except height is not this height. Height is this one, okay? So rhombus is gonna be the same way. Base times height, base times height, okay? All right, now here's the deal with a kite. Let's figure out the kite deal. I want to figure out how to make that kite into a rectangle that is base times height. How do I take this kite and make it into a rectangle? Like cutting it into pieces and making it into a rectangle. I'm going to draw these lines. Whoop. I'll draw my post for a kite. What do you got? Got any ideas?
Take the bottom left and right and like put
Yeah.
them next to each other.
Okay, I'm going to take this, I'm going to chop it off. And I'm going to rotate it around, and I'm going to lay it right here.
And then put
You see that? I'm going to take this top one, and I'm going to chop it off, and I'm going to rotate it around, and I'm going to set it right here. Okay, so let's come up with a formula for a kite. Ready? I am going to take this length right here, which they call a diagonal, right? They call it a diagonal. This is diagonal 1, let's say, right? Then what's this length right here?
Base.
That's the base, right?
diagonal 2.
So your height is diagonal 1, right? But what's your base right here?
Right.
It's not diagonal 2. It is half of your diagonal 2, right? Like we took that and we split it in half. You see how that works? So the formula for a kite for area is 1/2 d1 d2 or 1/2 d2 d1, right? Doesn't matter, okay? So it's just going to be half times the one diagonal times the other diagonal. You see how that works? Because the one diagonal will be half of it if you lump those onto the other side. So that's how a kite works, okay? Let's go this way. So they have my rhombus kite. Oh, this works for a rhombus as well. So if on a rhombus, I see what they're saying. If on a rhombus you are not given, making you dizzy. If on a rhombus you're not given the base and the height, but you're given this guy and this guy, you could take this side and lump it over here, and take this side and lump it over here. So the 1/2 d1 d2 works for a rhombus also. Just depends on what you are given. Does that make sense? So look at cutting it into pieces, all right? This guy, go to example 5. Okay, this is a which shape? That's a rhombus, okay? What's this diagonal this direction? What? 6. 6 is from here to here.
12.
You see that? So 12 is that diagonal, okay? What about this guy right here? 14, right? Okay, so if I'm trying to find the area, I take 1/2 times 12 times 14. Now, problem. Ready? Everybody watch this really quick. I've had people that do this before. They take half of 12 times half of 14, and they take 6 times 7, and that is not right. The half doesn't distribute like you do if it's like x plus something, right? You would just take like half of 12, that becomes 6, and take that times 14. Make sense? Or half of 14 times 6, I think it's like 84. Yeah? 84 millimeters squared. Okay? So if you're going to do the halvesy thing, only take half of the one side, not both sides. Right? Okay? This is a lot of stuff to remember. All right. Find the area of the kite. Half of something times something. Which one are you going to take half of? It doesn't matter, but which one are you going to take half of in here? For these dimensions right here on example 6. 16, because half of 16 comes out nicer than half of 9, right? Half of 16 is 8, and 8 times 9 I can do in my head without a calculator, right? 72 inches squared. That was fast, right? 1/2 of diagonal 1, diagonal 2, and it doesn't matter which diagonal you're looking at. Okay? That was example 6. Okay. Is this the last one? Yeah, example 7. All right, this one's a little bit of a doozy. One diagonal is 55.88. So this distance is 55.88. We do not know how long that one is. But we know that the area is 92. They want us to find that other diagonal. So let's talk about the area of a kite. We take 1/2 times one diagonal times the other diagonal, which is called x. And that's equal to how much? How much do they say the area is? 92.
Oh,
Like that? Okay, 1/2 diagonal 1 times diagonal 2. Can we solve for x then? What would you like to do first?
Take 1/2 of that.
What's half of 55.88? What does this come out to be?
27.94.
27.94x is what this is over here. Now, how do I solve for x?
Divide
Yeah, divide by 27.94.
3.29 is what I got.
3.29?
Yeah.
Okay,
Doesn't seem
that does not seem right, but it is. Oh, wait. They say x is 84. What are they talking about?
They say 8.4.
Oh my gosh. Guess what? 55.88 centimeters and inches.
I hate
Okay, all right, so we got a little bit more to do. Erase, blah, blah, blah. Do we want to convert to centimeters or do we want to convert to inches?
To inches,
Why to inches?
because we already have the area in inches, so it'll just be easier, right?
True. But what is the length of the other diagonal in inches? That's what I look at. So, yeah. We want to be in inches. Okay, so 55.88 centimeters. You can do your little railroad track things. I put it over 1 times. How many centimeters are in an inch, by the way?
2.54.
You didn't know that off the top of your head,
Yeah,
did you?
I did.
You did. Okay.
Just
All right, 2.54 centimeters in an inch. So, how do I find out how many inches that is? 55.88
Divide by that.
divide by 2.54, okay? And that is how many inches? 22. I don't know.
oh
55.88 divided by 2.54.
yeah 22.
22? Awesome. Okay, so next this is 22 inches. Okay, now let's set up our equation. I know that if I take 1/2 times the diagonal 1 times the diagonal 2, I get 92. And the diagonal 1 is 22 and the diagonal 2 is x. Okay, what's half of 22?
11.
11, and then what?
Divide by 11.
Divide by 11. Yeah, what's 92 divided by 11?
8.36 repeating.
8.37 inches? 8.37 inches. They say 8.4, whatever. How about that? That was a little bit going backwards. Can you handle it?
Yeah.
We can handle it until we didn't realize that they did different. Oh, yes. Thank you, Avalie. Squared. Okay, good.
How much homework?
Wait,
How much homework? I don't know what. Wait.
it wouldn't be squared. If we're just finding
Oh!
diagonal.
Oh, It wouldn't be squared. You are right. You are right. I can't think today. Yes, good call. Yes. We were finding the diagonal, not the area. So yes, it is just in inches. True, true, true. Very good. Okay. All right. Find the area of each trapezoid, rhombus, or kite. Blah, blah, blah.
Should just do like 2 through 4 evens.
2 through what?
2 through 4 evens.
I like that idea.
I like that idea.
About 1 through 2 odds.
Let's do
1 through 1 evens.
let's do 2 through 18 evens.
Golly, wait,
That's 9 problems. 9 problems, I think. Page 635. 2 through 18, the evens. There you go. Okay. Beautiful.
Watch this.
All right.
10 squared plus x squared